So I'm going to talk today about the Kubernetes resource model and its ecosystem. This was an intermediate track, but I kind of wanted this to be open to a lot of audiences. I'm not sure where people are at. How many people have heard of a CRD, have some idea what it is? Okay, like everybody, so I'll go fast over that part. Who's heard the term KRM, Kubernetes Resource Model? Some of you, less? Okay, so that won't bore you. So Kubernetes APIs is the term I like to use to refer to like the ones that come with Kubernetes. They're documented on Kubernetes.io. They're in the Kubernetes release. They're about containers. They're things like pod and service. A distinction from that is the Kubernetes resource model. It's not an API. It's a pattern for APIs to follow. It doesn't mean the API has to have anything to do with containers. It has a bunch of attributes of the pattern, which I'll talk about in a second. So an example of an attribute of the KRM pattern is that the body of a post is also a file format that you use to store things on the client side. And I'll list some others in a second. So I use the term model and framework and patterns. So let me explain what those mean to me. A model is something that a bunch of APIs have in common. It could mean the wire format or headers that are required or other things. REST is an API model that most people have heard of. I don't say that Kubernetes perfectly follows the REST model, like it doesn't use links for everything or link relations. Framework is a term I mean to use like libraries or tools or like meta APIs or API services, IDLs that help you create things that follow the model. It's not necessarily required, but it helps a lot. If you're going to use a REST API, you might use Flask as a library to help you. For KRM APIs, I like to use KubeBuilder. KubeBuilder uses CRDs. You don't have to use CRDs, but you should. And then finally, a pattern is something that tends to emerge as a good way to do things. It's not something that every API uses within the model, but it's that a lot of APIs in the model use it. So if you search for REST patterns on Google, you're going to find a lot of hits. If you search for gRPC patterns, gRPC is another model, and you're going to get an official gRPC guide with like a list of like 20 patterns. It's really good. By the way, I will post the most updated slides that later today, so don't feel you got to photograph everything. But feel free to if you want to. If you search for KRM or Kubernetes API patterns, you basically will get almost no useful hits. So that's something I'd like to solve for us as a community, and hopefully this talk is like a beginning, and we can have a conversation about whether these patterns make sense, document them, and collect more. So like what are some common attributes for KRM APIs? Most of you know this, but I'm going to recapitulate this for people that maybe are new to this. They all share at least one CLI. They can interact with them, kubectl. They all have metadata like labels and annotations. They all share one state storage, which means the API implementation is stateless and somebody else gets to worry about the backup. They all share a common authentication, authorization, audit logging model. They share a consistency model for better or for worse. Some people don't like eventual consistency, but at least the consistently expecting it sets expectations. They all share at least dynamic clients in some languages. They have schema reflection that can help IDEs help people edit the client-side documents. In the future, apply on the server side is going to apply to everything in this ecosystem. And there's a growing ecosystem of client-side configuration tools, whether you use Kustomize or Helm charts or something to templatize or edit your configuration. So one thing I noticed as I was looking at sort of all the KRM APIs out there is that CNCF uses them a lot. I identified 18 projects that are somewhere in CNCF's portfolio, and I highlighted those in a solid line circle. And all those use KRM in their core project. And then there's another 6 that they don't actually use KRM in the core project, but there's like a well-supported operator or some other third-party project that's supporting that with KRM. Prometheus, I would say, is a great example. There's a CoreOS Prometheus operator. People that I know that run huge Prometheus installations and have deep experience in it, definitely recommend you use that. And they use it for themselves in production. So overall, there's like 136 types just among CNCF projects. So you can see how KRM is just sort of, without anyone intending it, is bringing a level of consistency to this whole portfolio. In fact, you can say that I'd say half of the projects in the portfolio share this API model. I want to, as an aside, I want to say that like, I mentioned gRPC as a different model, and gRPC is a CNCF project, and I view gRPC as complementary to KRM. gRPC is flexible, it's great for imperative programming, it's great for high bandwidth, it's high efficiency. It doesn't have quite as many opinions. I think KRM is great for declaring infrastructure. Unlike gRPC, it models the reconciliation loop sort of as part of its model, as opposed to not making any assumptions about that. So like, here's some other projects. If you weren't aware of how broad the ecosystem is, these are all things that have more than 500 stars on GitHub that use KRM. It's certainly not an exhaustive list. What I wanted to bring out is like, there's a lot of things here that are not about containers. And within each category, there's like lots of good options. And these are just a sampling for some of these. So I've been working on Kubernetes projects since nearly the beginning, as Paul suggested. And I've seen a really rapid growth of the project overall. And I've seen the APIs as well grow really rapidly. At the beginning of the project, I wrote some APIs that are in the core, and then I moved to doing API reviews. I don't do that anymore. It's like there's too many to review. Jordan, thank you very much for staying on those. I moved on to trying to help teams within my company build KRM APIs, sort of consulting, and even that has like stopped scaling, and the only thing that's I think can scale is documentation and frameworks. And I recently did something which I've done a few times in my career, which I think is good and has helped me a lot, is I take off my engineer hat, where you're trying to sort of say how things should be, and I put on my naturalist hat, which is more, let's just look at all the things that exist out in nature. A naturalist, if you don't know, is like a scientist who collects and classifies things, maybe seashells. So let me describe my time as a naturalist in the Kubernetes or KRM ecosystem. So this was like several centuries ago, you were a naturalist. There was no place you could go that had a collection of all the shells. So you would have to go find a beach and walk along and pick up everything that looks like a shell, and you might count them. Then you might throw away some rocks. You might try to sort them and guess what species they are and look for patterns across species. And that's basically what I set aside some time to do. So there's not a list of all the KRM APIs, but there's a lot of stuff on GitHub. So what I did was search GitHub for every file that looks like it might be having to do with KRM. That included YAML files and Go files and JSON files. And I won't go into depth, but I figured out that if you just look at the YAML files, you pretty much get a picture of like 90% of all the things that are in the KRM ecosystem. So I'm going to focus on that for today. It's nice because I can parse it and understand the structure within there. So I downloaded all of them, put them in a database, kind of cleaned the data, got rid of duplicated files, right? Some people have copied stuff. GitHub tries to get rid of forks, but you still end up with a lot of duplicates. Conveniently, unlike a naturalist, like the things are labeled with their genus and species, right? They have an API group name, which is a unique domain, and a kind, or which I call a type name. So I did this in October. It took a while to get this data because GitHub like doesn't want you to search everything, and they have all these DDoS protections, but I ended up with like 27,000 YAML files, and then those have like different documents in them, so you break those up, you get a bunch of objects, and so you end up with 67,000 CRDs. There's some duplication there. You winnow all that down, figure out the stuff that's not parsable, and I found that there are 56,005 as of mid-October KRM types that are defined somewhere. And those are all different groups and kinds. So I had done a similar search to this like 2 years ago, so I knew that 56,000 was a lot and there was significant growth, but I wanted to like understand the growth trends a little bit better. So it's pretty impractical and not a good use of my time to try to figure out like for every single revision, like what was the first revision where that CRD appeared and what date was that? Like that's not practical. But what I could do was associate all the CRDs with when the repo was created, which is sort of a proxy for when somebody created that resource. And so I can graph that over time. And there's, it's a little bit funky because you see stuff before CRDs were introduced. So there's some noise in this method, but you also see some big spikes. Those are real. That was one project called KubeForm over on the right. They created a repo and it has like more than 1,000 types in it. So then I kind of figure it's not fair to like count those guys as one thing. And really what's more interesting is how many independent groups are building things. So I decided just to focus on API groups for this graph. And you can still see this really steady trend of new API groups showing up on GitHub. So if you extrapolate and say, well, we got past the exponential phase and it's just linear for the last year, I still extrapolate 1,000 new API groups will be created in the next year. So that's great. More things for us to, configure along with our Kubernetes clusters. But it's also a chance to influence the next group of people that build an API. So how can we provide good advice and support and tooling to those folks? So clearly one way we're keeping APIs consistent so far is through frameworks, through CRDs, through things like controller runtime. So it's definitely we should look back and say, like, what frameworks are people actually using in the wild? What do we build and did they like it? And I'm not sure I can tell you why they liked the things they didn't like, but I'll tell you the numbers of what got used. I'll say it first, you don't have to use a CRD to make a Kubernetes API. You can write it from scratch. I don't recommend doing that. You can use something called extension API servers or aggregated API servers. I don't recommend you do that, but you can. Around early 2017, the community was trying to decide, we had invested heavily in aggregation and in extension API servers, and they thought this was the most flexible way to build new APIs. And I kind of said, wait a second, that's really hard. Isn't it better if more people come to the ecosystem, even if they don't build APIs that are quite as full-featured as we'd want them to be? Let's focus on TPRs, which became CRDs. And so I think that at least I was part of the conversation that shifted the community effort there. I think it was the right call, because looking back, there's 100 times more CRDs than there are extension API servers. That basically grew not at all over the last 2 years, and CRDs have just gone vertical. So, where was I? A lot of things are optional for CRDs, at least in V1 Beta 1. Validation is optional. It's sort of required in V1, but let's talk about what you can use in your clusters today. I should mention CRDs went V1 in 1.16 if you didn't hear that, so that's kind of a good chance to reflect back on them. But 60% of all the CRDs at GitHub use some validation. They have some kind of schema at least telling you, this is not like just curly braces or like in the no schema, it's like some properties are listed. So I think that's fantastic adoption for something that didn't come out at the beginning. Additional printer columns is kind of one of my favorite things. That just means that when you kubectl get some type name, that you get columns other than like the creation time and the name, which is kind of boring. But you get columns that were picked by the author. I highly recommend that, by the way, if you're building a CRD. Status subresource, I'm really happy that people are following the status pattern. I think it's not used enough in the core, but people are adopting it well for CRDs. And conditions, that's an area I think we could work to sort of tell people whether they should use those, how to use them or not. Scale subresource surprised me, no one basically uses scale. And it seems like it's just as easy to use as status, but only 1% of the CRDs I could find define scale. And so I think maybe that's because not everything needs to be scaled, or if it needs to be scaled, it needs more than one dimension. But that's something to reflect on. Okay, so I kind of talked about where we are in the, what the ecosystem's like. Let me try to talk about some patterns. By the way, if you see this pattern on a shell, don't pick it up, it's poisonous. So I'm going to talk about two different groups of patterns. The first one that I like to promote the idea of is a controller pattern. And this is less about what the schema is. This is about what does the controller do. And so the first bifurcation I make is between controllers that create some kind of resource and controllers that don't create resources, but maybe they do something to resources. So on the create resources side, if it creates a KRM resource, I call that a composite. And I'll explain why I think that's different from the other option, which is where it makes a non-KRM resource for you. That could be a cloud provider resource. I call that second one a provisioner. On the other branch, the things that don't actually manage resource lifetime, one branch is where they act on requests. I call that an enforcer. That's kind of a shorter way to say mutating or validating admission webhook, which I think is kind of a mouthful. The other option is where they act those grab synchronously the request when you try to make something or to update it, but they don't do anything if the thing's just there in steady state. If you want to act on something in steady state, I call that a governor pattern, and it's actually quite different to implement. So let me go over each of those pretty quickly. Provisioner pattern is really popular. I'd say 25% of all the resources that I found on GitHub are some kind of provisioner. Part of that is biased towards people, leveraging Terraform providers, but still, even outside the Terraform providers, a lot of people that are like, hey, I just want to make like a GCS or an S3 bucket and define that next to my application. I've seen a lot of people try to do that. And so if you're doing that, if you use GCP, I'd recommend you check out Google Config Connector. It does that for you. And so in the simplest possible version, you just make this really succinct object. It doesn't even need a spec because everything's defaultable. The reconciler is going to go off and make a cloud provider bucket for you. And it's going to set some status, which I don't show there. And if you want to get down into all the details, like cores or whatever for like serving from a web bucket and who pays, there are fields for that, but it's simple to start with. So if you're interested in provisioners, a bunch of examples. I mentioned Config Connector. Crossplane.io is a pretty cool project. It takes an abstract angle where it's like trying to hide the sort of the differentiators of each cloud and view every cloud as having a least common denominator of resources with a focus on portability. KubeForm is saying, let's just take the Terraform providers, which have pretty much all the options for each cloud provider, so there's not symmetry across similar resources from cloud providers. And until very recently, I would have said, check out AWS Service Operator if you're using AWS, but unfortunately that seems to be archived, and I'm hoping they'll revive it because I think it's useful. So, composite pattern. So this is very familiar. Deployments, stateful set are very common. CNCF examples are Jaeger and Vitess. There's a controlling resource, which is the one that's defined in your CRD. The controller watches the controlling resource, and then it makes one or more KRM resources that are the controlled or lower resources. Some people like to say parent and child. I find that gets like a little bit too far into the analogies. So some of the concerns for composite resources, like basically are definitely, you want to represent, and this is, the word composite comes from the Gang of Four design pattern, which is about part-whole hierarchies. And so you're going to want to use object references to refer sort of down or across in the hierarchy, and then owner references to refer up. There's some support for doing that in frameworks like controller runtime, but I think we need to make that more consistent and more ubiquitous. Some advanced concerns are how do you deal with like attaching and detaching resources to move them between controllers. I think a really important one is like how much reconfigurability or changing the defaults do you want to give users? And a lot of that's around pod templates. At one end of the spectrum, I've seen where people, like you could have basically a zero-line CRD and it makes something useful. And this example is from Jaeger tracing. You just say Jaeger, name simplest, and then you don't give any spec at all, and it's going to go and make you the most basic sort of one binary, one pod Jaeger tracing thing. But it has a bunch of options. In fact, you can go, like I can't even fit it on the whole page. Like you can override node affinity and stuff, but it doesn't use a pod template, but it has a stanza for resources. And so I don't know that we have a consistent thing, a consistent pattern yet for templates in our ecosystem, which is why I didn't add them. Like, should you use a pod template? Or should you just put in the things that you want people to override? I'm hoping we can at least solidify some advice to people on that. So the third pattern I call enforcer. This is going to allow or deny and maybe edit creation update requests. So unlike the previous two patterns, the controlling resource is not one-to-one or one-to-several with the resources that get created because there's nothing created. It's more like the controlling resource is just configuration at the cluster or namespace level for this policy engine. And so you try to create something and then maybe you get to create it or you don't. So a lot of this is like sidecar injection or security policies, pod security policy. If you need a general way to do this, I would definitely recommend you check out the Gatekeeper project. I linked that at the bottom. It's part of OPA, which I guess is part of CNCF, I think. I hope I didn't misspeak there. Fourth one is governor pattern. So this is where you're continuously updating a resource, but you didn't create it and you don't own it, and you can detach the governor or add it to a resource. I'm not sure why this is covering up, but it's supposed to say horizontal pod autoscaler, vertical pod autoscaler, and then a project called KEDA. I'm not sure how to pronounce that. This is one I could find the least examples of, but I wanted to include it for completeness. Okay, so let me talk about a totally different set of patterns. I call this, I don't have a great name for this, but kind pair patterns. So this is where you have two different types that work together, and you split them, and like, why didn't you put them all in one resource, all the information? So I call this X cluster X. So you might have like the basic example, the first one I know about is like role and cluster role, or role binding and cluster role binding. And it isn't always, X doesn't always have to be the same string, but you'll see this pattern a fair amount, like why would you use this? You'd use this if you want the administrator to be able to create like defaults or limited selection for users, or you just don't want to repeat yourself, and you want to give different permissions for the X resource so that each team, sorry, I didn't describe that right. If you want to make cluster objects only writable by the administrator, but you want each team to also have some additional set of objects in their namespace, you'd use this pattern. So here's some examples. I found like around 40 of these as I was just like looking for the pattern of X and cluster X within the same API group. Next one is what I call X and X claim. So an X claim is something that a user creates to represent they want to request a resource, and then it gets fulfilled with some X resource. And so this is splitting them so they can have different lifetimes. Maybe you want the X thing to be recycled. You want to have different permissions for who could manage each one. I think this is a useful pattern. It worked well for PVs and PVCs, which use that pattern. And I found a fairly small number of examples, actually. One that was sort of used in quite a few places is this object bucket claim. And it actually doesn't claim object buckets. It can claim different types of things that implement buckets on different platforms. So there's some variation how people are applying this one. I'd like to understand like what the best way to use it is. And let's see, last one is X and X class. So an X class holds defaults or preferences. Did I do that right? Yeah, for some type X. And then the X objects might copy those from the X class when it's created. And this again is about separation of privilege. It's also about like the user not even have to think about it. It's about being able to create like site-specific or cluster-specific defaults that developers don't have to think about. And there's sort of two ways this plays out. I've seen it used like with the enforcer pattern, where the X class values get copied into the X as like site-specific defaults. Priority class pattern does this. So it like sets a numeric value from a string value into a pod. Or there's another way is like with a provisioner pattern, you don't ever see the child object or the lower object that's created, but the X class is telling you the defaults to put in there. So I saw a decent number of these. It's used quite a bit in the core, or I guess 3 places in the core API. Crossplane.io uses this a lot. I'd recommend you check that out if you're interested in a agnostic cloud storage solution. I haven't used it myself, but it's interesting from an API standpoint. Okay, so I covered like adoption, growing, frameworks, patterns, models, how those fit together. Some patterns I've seen. I think there's quite a few more for us to discover. I kind of want to reflect now on like what's worked and what should we do going forward. So I talked about, this is just a slide, the top half of this is just the slide from before, where I showed how often I saw people using these patterns that are supported by the framework, or I guess features of the framework. And the bottom thing is these 3 paired patterns that I just talked about, which are not supported by any framework anywhere. You just have to sort of know about them. And I saw the adoption of these patterns is like a lot lower. So I'm not sure if that means that these are less applicable, or whether people just need help for tooling to adopt these more uniformly. But clearly, patterns are getting adopted a lot more slowly than things that are supported within frameworks. So let me try to sum up again. KRM APIs are not limited to containers or Kubernetes. You can use them without using Kubernetes. If you want, you can create a cluster and not have any nodes in it and not have any pods in it. The ecosystem's growing really rapidly. There's like 2,000 APIs. There'll be another 1,000 next year. And I find the consistency across those really valuable. It lets people reuse their understanding and reuse tooling. Framework adoption is happening much faster than pattern adoption, and more mature API models do document their patterns, and I think we need to invest more in that as a community. So let's try to move forward on that. If you're building an API, I'd recommend you try kubebuilder.io. I think it's where there's the most activity around bringing in new features into the framework. And if you want to hear more about KRM, you can follow me on Twitter or DM me if you have comments or ideas. Looks like I talked fast and I've got a lot of time for questions, so I guess I'll take questions. Thank you.
Hi, okay, okay, great. I like this, good talk. I like the idea of patterns. In fact, I think I've noticed there's another kind or sort of pattern exemplified, for example, in storage and pods. So between what you might call it a hard dependency, right? So PVC is a hard dependency on the PV, a pod using a PVC is a hard dependency on the PVC. And finalizers are used to implement this, and it's a kind of a piece, an aspect, but it's another kind of pattern that I think is worth, and it's just one example of that sort of pattern I think is worth understanding and talking about as well.
So are you saying that object references are a pattern, or is there more to it than that, I guess?
This is a more specific, there's more to the pattern than just an object reference, right? It's a specific kind of relationship and the way you implement the relationship, right? So if you look, for example, in a relationship between PVC and PV, there's a kind of a pattern in the code, and there's the same kind of pattern in the way it uses the finalizer and the object reference and the way it's wrapped around, right? Same kind of pattern again between pod and the PVC. Okay, so that's the kind of thing I'm talking about.
Thank you. Are there other questions?
Yeah, hi. While you were going through all those different controller patterns, I found myself thinking of some of the controllers we've written and thinking, we've kind of implemented all of those in one controller here. So, and maybe that's not the best idea. So is this sort of more, do you mean this sort of as a survey starting point, or is there anything more sort of guideline-y or prescriptive-y you can say when you find yourself maybe implementing too many of these, or, yeah, if that makes sense.
Okay, I heard two parts of that question. One is, when will you give me some prescriptive advice instead of descriptive information? So I wanted to get feedback from people on whether this made sense, and if it does, I would love to share more prescriptive advice with the community. I'm not sure whether that belongs in the Kubernetes repo or KubeBuilder or something, so I'd love to talk to people afterwards about that. And then in terms of how, should you implement these patterns in the same controller, I definitely see that. Like, I think, for example, Cert Manager uses, I think all these patterns as well. But I think it is useful to at least have names for the parts of the controller that do it. I also have found implementing control loops that it's definitely, even if you don't expose it to your users, I think it's less error prone to try to implement separate control loops for each of these patterns because they really have different concerns. I think we probably need to categorize libraries as supporting different ones of these patterns. You can link in more than one library. And I think you don't want to try to shove, if you can help it, all these patterns into one custom resource. So I think it's useful, at least from a debuggability, understandability. If you're going to build something that's gonna provision cloud resources for a bunch of different clouds, you could sort of use the cloud provider plugin model where it's sort of invisible what the relationship is between the top level CRD and then the created cloud resources, and you can't see them. But I actually like it better when you have an intermediate step where the top-level resource then creates like a provisioner-style resource, and the provisioner then goes and makes the cloud resource. That would allow cloud providers or people who are experts in each type of pattern to leverage each other's work. And I think it's a good separation of concerns. Are there any more questions?
Okay, so when I think of resources in Kubernetes, I think of them as describing the desired state, and controllers as what reconciles the actual state to be in line with the desired state. But I've seen other instances where people will create actions with the resources, like, for instance, an ad hoc backup of a database, and you have a controller do that. So do you have any opinions on whether that's appropriate or not?
Yeah, I mean, I consider putting in a slide on that, which I call like the job-like pattern. And I think it's definitely useful to have a pattern for resources that reach a terminal state, because a lot of times you want to know, like, is this done? I think the contract there should be, like, if you offer a status that says that you're completed or succeeded or failed, like, you should never be able to leave that state again. That way, because it'd be weird if you said, my job's done, and then you were like, okay, great, I'm gonna do the next thing, and the job's like, just kidding, I'm not done. Especially with eventual consistency, where like you sort of, you might have to wait a long time to get the message that it's done, hopefully not. Like, you definitely don't want the messages crossing in the night, so you need to use monotonically increasing signals and an eventually consistent system to sort of help you advance your state forward. So I think we definitely need a pattern there, and I will, please DM me if you have ideas, but I'll try to write some more about that in the future. Okay, who really wants to ask a question or needs time to get to the next building? Okay, I got one more.
What's your take about the duck typing pattern in Knative?
I went to that talk, I really liked it. Those guys are all really creative folks. My first reaction was, hey, I've got this database of like all the CRDs on GitHub. I wonder how many of them actually fit their formal definition of pod specable. Because I've seen a lot of different ways that people allow you to sort of override some or all the features of the pod, or they actually have 2 different pods or like 50 different pods that, specs that make up their thing. If you look at Kubeflow job, like there's, or Spark job, there's different roles. And so I'm interested in seeing how we could formalize that to make it general enough to be usable. But I don't yet have an opinion on like where the trade-offs are for that. I think that's a good area to look at. Thanks everyone for coming and for making the trek over to this hotel.